Welcome to the Data Scientist Podcast with Dr. Stylianos Kampakis. Dr. Kampakis is a data scientist, statistician, and blockchain expert with a mission to educate the public about the wonderful capabilities of technologies like AI, data science, and DLTs. These technologies have the potential to transform the world, the economy, and our lives. However, there is too much misinformation around tech, and so most people are just confused about what is true and what is not. Whether you are a CEO, an entrepreneur, or just an enthusiast, the Data Scientist Podcast helps you separate reality from hype.
Hi everyone. In this episode, I want to talk about deep learning, the truths and the myths, and where I see deep learning going in the next 2 to 3 years. So deep learning became very popular as a technology in about a decade ago. So neural networks have been around for a long time. Actually, the first neural network was created around in the 40s, I think, if I'm not mistaken, by McCulloch and Pitts. After that, there have been many other versions of the original artificial neuron, until in the 80s we ended up with some neural networks like multi-layer perceptrons and self-organizing maps or a coherence network and recurrent neural networks and many different types. So neural networks were very popular up until the 70s. Then they were discredited because of some research that demonstrated that their power was fundamentally limited, but then some of the obstacles were overcome. And around the 80s and the 90s, neural networks started becoming popular again. However, around the 90s, the popularity started to slow down again, which is interesting because in AI, we've seen these trends coming and going all the time, and neural networks is a prime example of this. So effectively, there was a period until I think around the mid-90s or so, where people wouldn't even say, they wouldn't even say they're doing AI, they would say I'm doing neural networks. But then we had some other methods like support vector machines, which are better grounded from a theoretical perspective, and they started essentially stealing the show from neural networks. So then neural networks went through some kind of winter until Jeff Hinton discovered, probably to many people's surprise, that it's possible to create very powerful machine learning models by getting a simple neural network and simply stacking many layers on top of one another. So it might be a bit difficult to explain this in a podcast, but essentially neural networks, they possess multiple layers, basically mimicking the way that an actual brain processes information. So every layer can be seen as some kind of processing unit. And as we add more layers, this is what our brain does, we can run more complicated computations. And for decades, scientists believed that it was impossible to train neural networks with multiple layers. But Hinton figured a way of how to do this, and eventually this is what gave rise to deep learning, and the rest is history basically, because since the discovery of deep learning, we've been having some amazing technology, some amazing tools and methods that we didn't have before. So anything around computer vision, autonomous vehicles, natural language processing, audio processing, all of this is based on deep learning. So it's clear that deep neural networks are very, very useful. And for the first time in history, many scientists believe that we're actually close to creating what we call general artificial intelligence. And the reason is partly the advances in deep learning. That being said, just because deep learning is a very useful technology, doesn't mean that it's a technology that you need to use. Okay, because I've been having many people approach me and say, hey, I need a deep neural network for this, or I need a deep neural network for that. And the truth is that maybe you don't need a deep neural network at all. So deep neural networks are amazing for anything relating to computer vision, audio. They're great when you have large data sets because they are very good in extracting complicated patterns from data. However, at the same time, they're not without their drawbacks. They're difficult to train, expensive to train, they need a long time to fine-tune, and hiring someone to optimize a neural network for you is going to be more expensive than hiring an average data scientist to use some standard machine learning techniques. So these are some of the things that you need to take into account when using deep learning. Also, something else which is very important for all those who are listening and they're on their own business is that if you want to create a deep neural network, quite often you're better off using a commoditized service. So for things like computer vision, audio recognition, sentiment analysis, companies like Google, Microsoft, IBM, Amazon, they provide their own APIs. So you can simply upload your data on those APIs, on those services, and then you get back, whatever it is that you want, maybe face recognition, sentiment analysis, whatever. Which means that you don't really have to train your own network. Unless, of course, you know what you're doing and you have some very specific requirements. And that's very important, right? There are many times when people approached me and they said, hey, I want to develop this capability in-house. And then they realize that this is out of their budget. Yeah, they just don't have the money to do this, to hire the people and the computing power required to do this in-house. But they can do it very easily by using a commoditized service. So that's something else to keep in mind. And something interesting about deep learning and machine learning in general is that in machine learning, in AI, we see these hype cycles. And I mentioned earlier how neural networks have their ups and downs. And many people are saying that maybe we're going to see research and the popularity of deep learning slowing down in the next few years. And I think this might be true because it looks like there's not as much research coming out in deep learning as we used to see like a couple of years ago, probably because there are fewer things to discover right now. So one of the latest big impacts on this community was the discovery of generative adversarial networks, which can be used to generate basically anything, fake images, video, text, but fake data which look realistic at the same time. So if you've not heard about deep fakes, I just Google it and you'll know what I mean. But again, it seems that progress in this area is, things are moving forward, but again, there's not something radically new to be discovered other than improving the quality of the results. And we see like marginal improvements all the time, every few months, but these are not some kind of radical discoveries. So it's very interesting to see where deep learning will go in the next few years. And it's very likely that reinforcement learning through deep learning, like deep reinforcement learning, is going to dominate for the next few years because it's one of the technologies that many people like Google DeepMind believe can help us create general AI. But then again, no one knows whether this is really the case or not. I believe that in the next few years, we're also going to see the rise of causal inference. I talk about this in another episode, and that is the study of cause and effect. Yeah, deep neural networks, while they are, very sophisticated technology, they still work in an associative manner. Whereas us humans, we can understand cause and effect. So we can understand that, hey, I did this and then this happened. And neural networks, for all their sophistication, they can't do this. So there have been some people like Julia Pearl, one of the most prominent computer scientists of our time, who has been advocating the inclusion of causal inference in machine learning research. And he has been promoting it. He also wrote a book called The Book of Why, where he explains his views on this topic. And there have been some other researchers like Yoshua Bengio, who is one of the best researchers in deep learning right now, alongside Jan LeCun and Jeff Hinton, who seems to be very keen on the idea of merging causal inference with deep learning. And this might actually be one way to bring neural networks closer to human-level intelligence. I don't know, but it definitely sounds like a very exciting possibility. So in any case, this was a brief intro to deep learning. I think I covered quite a few things within 10 minutes. I discussed a few things about the history of deep learning. I mentioned like a few tips for all the entrepreneurs out there. Be very careful if you want to develop a deep neural network in-house. Make sure to consult with someone first. Feel free to drop me an email because it might end up being more difficult than you think it is, whereas you might be better off using a commoditized service. That's part really of understanding these kind of requirements is really part of a data strategy, which is one of the services I provide. So happy to help there. And yeah, finally, I close with some thoughts around the future of deep learning, which in one way or another definitely looks very exciting. So thank you for listening to this episode. Let me know what you think. Feel free to drop me an email. Also make sure to check thedatascientist.com to read more about deep learning and data strategy if you're interested in these topics. So thank you for being here with me, and I hope to see you soon. Bye.
Thank you for listening. Make sure to visit thedatascientist.com for more content about data science, AI, and blockchain.